It is part 2 of section 15.9. In the first part, we introduced the change of variables and considered the key idea. Here we summarize it. In order to evaluate the double integral over R by the change of variables, you should first find a region Q and an one-to-one transformation T such that the image of Q is R under the transformation. Q is called a predomain of R, and in the case, in integral, the scaling factor is the absolute value of the determinant of the Jacobian matrix. So we are using this notation. Let's try to solve some problems and see some details. Evaluate the double integral over R, where R is the quadrilateral region with vertices given by these 4 points, using the transformation. Okay, here transformation is given. For this problem, let's first try to visualize the region R. That is y-axis, and that is the x-axis. Okay. Now 0, 0 is this one. Okay, 3, and there is a minus 3, and there is a 3. And second point is this one. Third one is that 6. Okay. And the final one is a 33. Okay, that is a 3. So that point. So region R is the quadrilateral connecting these 4 points. Okay, that's R. You can get the integral by first dividing this one into two subregions, and separately you can get the integral, and the sum will be the answer. But rather than that, we'll try to use the change of variable. Okay, here transformation is given. So x is u plus 3v, and y is now u minus 3b. Okay, so that is transformation T, and so we'll have Q. For this problem, you have to find the predomain. Already it is given, so you have to recognize in UV domain the predomain. Okay, in order to find the predomain, here we may consider inverse transformation. So we try to express u and v as a function of x, y. Then these points can be transformed by the inverse transformation, and so that we can recognize the region in UV domain. Okay, so let's try to solve these two equations for u and v. And equation 1 and equation 2, if we try to add two equations, then here that is x plus y, and the left hand side, right hand side is 2u. So from here we can get u equal half of x plus y, right? So we recheck this one. Now how about 1 minus 2? Then left hand side is x minus y, right side is 6v, so that v equal 1 over 6 x minus y, right? Okay. Now, the reason we are solving for u and v, this equations, is to recognize the pre-domain, okay? This point is 0, 0. When xy are 0, then the image under this inverse transformation is this one. Now, for 3 and minus 3, x is 3, y is minus 3. Then, now x is 0, and y is, now that will be 6, so that divide 6, so that the point is this one. And for that one, x is 6, y is 0. X is 6, y is 0. Then u must be 3, y must be 1. So that we have that one. Okay, this is 3. Okay. Finally, for this point, and x is 3, y equals 3, then must be, now u is 3, and 33, then it will be 0, so that this point. So the region Q is this one. We rotate it this way, but now we rotate it that way, okay? So that is now Q. With this transformation, the Q, the image of Q must be R, okay? Okay, we recognize Q. Now, to get the integral, we have to find the Jacobian. Okay, Jacobian is determinant of, okay, x and y, u derivative. X u derivative is 1. X v derivative is 3. Okay. Now for y, u derivative is 1. V derivative is minus 3. Okay. The determinant is minus 3, minus 3, minus 6. Absolute value of this Jacobian will be used in the integral. Okay. So the given integral, which is integral over all, will be same as now integral over q. And okay, let's try to put this one momentarily x plus y, and the scaling factor must be 6 and du dv. Okay, what is q? Q is a rectangle, and in x direction from 0 to 3, in y direction is 0 to 1. Now x plus y is simply now 2u. We have to express this integrand as a function of u and v, and we have a scaling factor 6 here, and now that is v direction and u direction. Okay, from now on it's quite simple. And 12 is the scalar, so that it can go out, and only we have u here, so that it's separable. Okay, so we have from 0 to 3 u du, and now from 0 to 1 and dv, right? Okay, 12 and half u squared, and u is from 0 to 3, and that last one is 1. So if you evaluate it, then you will get the answer 54. Okay, quite easily you can get it. Now let's see, before moving to the next problem, let's see this one. The determinant, the Jacobian, is negative 6. The reason is, okay, for this boundary, we have that orientation, but for that one is opposite orientation. And this one is now moving counterclockwise, and this is clockwise. So the orientation is opposite. So we have determinant minus. But if we consider the area and integration, okay, in integration, this one is areal element. So that once we consider area, then we have to use absolute value of this Jacobian. Okay, so we are using here 6 rather than minus 6. Okay. Evaluate the integral where R is trapezoid region with 4 vertices. Okay. Let's try to first visualize the region R. Okay, this is y direction. That is now x direction. Okay, x coordinate and y axis. And 1, 0. X is 1, y equals 0. That is 1. And 2, 0. Here, that is 2. And x is 0, y is minus 2. Okay, that is minus 2. And 0 and minus 1. So that is minus 1. So it looks like here, the region R is start from here and now connecting these points and coming up. So that last one must be like that. There's R. Over R, it is defined. For this integrand, we cannot get the integral directly. So we need some transformation and pre-domain, and we have to figure out the integral through the change of variables. Now, you have to decide the transformation, but it's not easy, and there is no hint. But a hint is given through the integrand. It has blocks x plus y, x minus y. So we may try to get transformation by using these two blocks. Okay, so let's begin with u equal x plus y and v equal x minus y. Okay, let's begin with that. Then, now from this one, here, the transformation must be made such that x, y are functions of u and v. So that we have to solve these two equations for x and y to decide the transformation. Okay, number one, number two equation, by adding, we have u plus v is 2x. That means that x equal half u plus v, right? Now, by subtracting u minus v equal 2y, so y equal half u minus v. So that is the transformation. Now, we decide the transformation. Let's try to figure out here the pre-domain. Okay. Okay. That is v-axis and that's u-axis. This v. Okay, that's the transformation. But we have to find the pre-domain for the region R. Okay, let's try to do find the corresponding coordinates for these 4 points. Okay, let's try to use red pen. Now, so that in a sense T inverse, and if xy are 1 and 0, then uv must be, okay, that is 1 and 0, 1, 0, 1, 0, so that uv must be 1 and 1, right? And xy are 2, 0, then 2, 0, then there must be 2 and 2, and 0 and minus 2, then, okay, there's y is minus 2, so that there's a minus 2 and 2. And 0 and minus 1, and that is similarly, we have minus 1 and 1, right? So let's try to connect these 4 points. 1, 1 is this one, 2, 2 is that one, u is minus 2 and 2, this one, and minus 1 and 1. So we have that quadrilateral. Okay, that is minus 1 and 1, and that is 1 and 2, right? Okay, that is Q. Now we'll try to get the scaling factor. So it's a Jacobian is determinant of, for x, u derivative half, and v derivative again half. For y, u derivative is half, and v derivative is minus half. Okay, so from this one, minus quarter, so that must be minus half. And again, this is a negative. The reason is, okay, the points are given points having this orientation, but this the corresponding point makes that orientation is opposite, so that determinant is minus half. However, we'll use half for scaling factor. Okay, so the given integral is now integral over q rather than r. Now e to the x plus y is u, and x minus y is v, and scaling factor is half, and du dv, right? Okay, for this integrand, integral with respect to u is easy, so that now also here v is outer integral, then and is easily we can access this domain from here to there for each v. Okay, so that is from 1 to 2 for v, and u, yes, okay, we have to figure out bottom u and top u. Okay, v is moving from here to there. For each v, bottom u is this one and top u is that one. Okay, that one is, okay, u is minus v. Okay, that one is u is v, right? So bottom u is minus v, and top u is v, and e to the u over v, and we have a half here, and inner integral is u integral, so that du, and outer one is dv. Okay. Now we'll focus on this one. Okay, that is integral from 1 to 2. Antiderivative of that one will be, okay, half is there, and then e to the u over v. Once you try to make derivative, try to get the derivative, then 1 over v will come out. So we have to put here v, right? So it is the antiderivative. Okay, so we try to put here now u is minus v to v. After evaluating this one, we'll try to get v integration. Okay, now let's try to put half outside, so that from 1 to 2, and v is there, and once u is v, then that's 1, right? And u is v, and this exponent is 1, so that is e. And once u is minus v, then that will be minus 1, so that e to the minus 1. Okay, we finish the evaluation and the v. Okay, this is a constant, and for this one, so the constant is half e minus e to the minus 1, and this one antiderivative is half v squared, and we are evaluating from 1 to 2. Then now 30 over 2, so that we have 30 over 4, and e minus e to the minus 1. That's the final answer. Okay. Okay. Evaluate the double integral over r, where r is the region in the first quadrant bounded by x squared plus 4y squared equals 4. Okay. Now, first let's try to visualize the region. This is for the first quadrant and bounded by that one. So there's x-axis and y-axis. Once x is 0, then y is 1. And okay, so that this one, once y equals 0, then x must be 2. Okay, that is 2. This is 1. So it is part of ellipse. Okay, like that. This is r. Over r, this is defined. Now, to solve this problem, once it is an equation of a circle, then it's easy. So that we may consider this transformation, that is a kind of hint. Okay. Now, once we are using this transformation, then x squared plus 4y squared, we try to express this function of xy as a function of u and v. Then let's see what it is. X is 2u, so the 4u squared, and y is v, then that is 4v squared. So that is the same as 4u squared plus v squared, right? Okay, once we are using this transformation, then so that x squared plus 4y squared equal 4, that boundary is the same as now 4u squared plus v squared equal 4, which means that in u domain, uv domain, u squared plus v squared equal 1. With this transformation, I'm sorry. With this one, the Q is this one. It's U and V. Again, this is a first quadrant, like that. That's 1 and 1, right? Okay. Now, so we figured out Q, and also transformation is given. Now, to evaluate the integral, the remainder part is getting the Jacobian, right? Jacobian is determinant of y u derivative is u, 2, and in fact x u derivative, and x v derivative is 0, y u derivative equals 0, and y v derivative is 1. So we have 2. Okay, Jacobian is 2. Remember, for this transformation, Jacobian is areal scaling factor. You can easily see that. Now, if you compare area of Q and R, then R looks expanded by a factor of 2 in only x direction, so that area of this one, R, is twice of area of Q. So that's the reason we have this Jacobian. Okay? Okay, so the given integral is the same as integral over Q. And now sine x squared plus 4y squared is now 4 u squared v squared. Okay, so that is 4 u squared plus v squared. And we have a scaling factor 2 and du dv, right? Q is now a polar region. In angle is from 0 to pi over 2. R is from 0 to 1. And then this one is a sine and 4r squared. And we have 2. And this portion must be changed by r, dr, d theta. You should not forget this one. Okay, that is a theta independent. So that for theta integration, we have pi over 2 easily. And antiderivative of this one, the major part must be cosine for r squared. And we have to put a coefficient here, and then we have to evaluate from 0 to 1. Okay, first let's try to decide this coefficient. In order to do that, we differentiate this portion. Then there will be minus sine and 4r squared, and then 4r squared will make here 8r. Now compare with this one, we have extra minus 4, so that we put here 1 over minus 4, right? Okay, so that is here pi over 8, and with this negation, we first use this lower evaluation, which is cosine 0, that's 1, minus, and now cosine 4. Okay, that's the final answer. Okay. The change of variable can be used for also triple integrals. And when we try to do that, we have to decide the Jacobian of the transformation. So here, assuming we have predomain and transformation T, so that x, y, z are functions of u, v, w, then the corresponding Jacobian is given in this way. The determinant of x, u, v, w derivative, and y, for y, we have also u, v, w, and for z, u, v, w derivatives, and try to get determinant. Of course, when we try to get the integral, triple integral by the change of variables, and we have to use the absolute value of the Jacobian. Okay. Under hypothesis, similar to those in theorem 15.71, and we have the following formula for triple integrals. Triple integral of f over r is the triple integral of f over q and the same function, and expressed as a function of u, v, w and absolute value of Jacobian. So the change of variables can be easily expanded for triple integrals. This is a self-study. Show that when dealing with spherical coordinates, we have this formula, and dv will be changed by rho squared sine phi, d rho, d theta, d phi. And here, that is coordinate transformation from rho theta phi to x, y, z, so that you can organize this metric, and rather than u, v, w, we have already the variable rho theta phi, and again rho theta phi derivatives. And if you try to get determinant, then you will have this scaling factor. Okay. So try yourself this problem. It's a self-study problem. Okay, we have some exercise problems, and for number one, hint is already given. This is similar to one problem in exercise, the practice problem. Okay. Now, for this problem again, and you can see quite easily the possible transformation. X squared minus y squared is same as x plus y, x minus y. So that you may introduce u equal x plus y and v equal x minus y. Now reason is given along with these four lines, so that quite easily you can see that your Q, the predomain, is a rectangle. Okay. Now the final problem is, okay, again, the integrand has x plus y, so that you may try to introduce, again, quite similarly like this one, x plus y is u, then another variable can be x minus y. And for this one, r, okay, this one, it's made in this way. This is R. Okay. So, for example, x and y are simultaneously non-negative, then the given equation can be changed into x plus y is bounded by 1. So that is exactly this one. This is 1 and 1 here, the below, like that. And now once, for example, again, x is non-negative, but y is now non-positive. Okay, let's try to get negative. Then that will be x minus y is bounded by 1, which is same as y is here larger than x minus 1, like that. That means this one here, this portion, which is minus 1. So that if you try to consider all the cases, then you will get here this region. So this whole thing is R over there. So quite easily you may use this transformation. Of course, inverse of this one is the Ewell transformation. So that you can get the corresponding Jacobian, and integral over R will be easily transformed into the double integral over Q. Okay? Okay, this is the end of the section. Thank you.